Okay, I'm going to look at some of the questions on the Pulleys worksheet that you were given a couple of weeks ago. I've just picked out a couple of questions to look at to give you an idea of what's going on. So question 2 says, two particles of masses 3 and 4 kilograms connected by a light, inextensible string which hangs over a smooth peg. The system is released and rest with the two particles level. Find acceleration and tension. First part is standard. Obviously 3 kilograms, 4 kilograms, the 4 is going to, because it's heavier, is going to go downwards. So the 3 one's going to go upwards. It's got the same value of acceleration. Remember I said the other week, it's not the same acceleration because they're in opposite directions. The inextensible part of the string means it's the same value for T. I've got the weights, 3G, and I've got the weights, 4G there. The first part is standard, especially when they give us the masses, is fairly standard. I'm going to resolve upwards for the 3 kilogram, using F equals MA. Remember, these little sentences don't get me any marks, it tells me what's going on. So upwards, I've told myself, resultant force, T minus 3G equals its mass times the acceleration. I'm going to call that equation 1. I'm going to resolve downwards for the 4 kilogram one, also using F equals MA. Remember, resultant force is mass times acceleration, so the resultant downwards force is 4G minus T is its mass times acceleration. Without even looking at it, reading it, doing anything at all, I'm going to add the two equations together. I'm always going to have a plus T and a minus T, and adding them always eliminates T. So I've got 4G minus 3G, G equals 3A of 4A, 7A. Okay, G over 7, which is 1.4 meters per second squared. There we go. I can stick that into preferably equation 1 to get T, because T is positive in that one there. This is annoying me. At least, hopefully it shuts it up. So T minus 3G is 3 times 1.4. T equals 3G plus 3 times 1.4. So it's 3 times 9.8 and 1.4, 11.2, which is 33.6 newtons. There we go. Like that. And that was part A. It wanted the acceleration and the tension. Now part B wants a distance between them. So let's use the fact it's a constant acceleration. We can use SUVAT to find the distance that they fall. So S is what we're after. U was released from rest, not cared about V. 1.43 seconds later. So it's the one without B in V, sorry. S equals UT plus a half AT squared. S equals nothing plus a half times 1.4 times 3 squared, which is 0.7 times 9, 6.3 meters. But it doesn't want the distance, the displacement, whatever's that one of them falls or one of them rises. It wants the total distance between the two. Well, the lighter one has gone up by 6.3 meters, as the heavier one has gone down by 6.3. So the total then between them is 12.6 meters. Okay, so the total distance between the two, and it says how far apart are they, that's how far apart they are. And the last part, C, wants the force that the string exerts on the peg. Now if I look at the peg itself, there's the peg. If I look at the peg itself and consider the forces on that, well, all it is whatever T is, there. The force is 2T. It's not mass times acceleration because the peg's not going anywhere. So it's 2 times 33.6, which is 67.2 newtons. And that's it. Okay. Obviously, this gets more complex if the strings, one of the strings is at an angle or it's horizontal or whatever's like that. You've got some cosine rule, or you can use vectors to find the combination of the two tensions there. But in this case, they're both acting in the same direction, just add them together, and that's it. But the key part is the start. It's always the same. I'm always going to have a plus t, I'm always going to have a minus t. I'm going to add the two equations and eliminate t. There are a few things they can do to cheer it up a little bit, but that's pretty much it. That's one question. I'm just going to look at another one as well. Question 7 says, two particles are connected by light in a sensible string. There we go. Pass over a smooth peg. The particles have masses 3 kilograms and 1 kilogram. The 1 kilogram particle will fall down to the ground level where it's 40 centimeters below the level of the 3 kilogram one, and then it's released. So I've written 0.4 meters from 40 centimeters, so I've got the right units. It wants the magnitude of the acceleration as the particles move. So let's begin to put our forces on here. At the instant it's released, we can say that it's not in contact with the ground there. It's just a distance between them. So I've got G, I've got tension, and that goes up with an acceleration. Whereas this one's got 3G going downwards, got a tension going upwards, and the acceleration is going downwards. So as before, I'm going to resolve upwards with the 1 kilogram one, using F equals ma. Not even thinking too much about the question at the moment, just on autopilot. T minus 1G equals 1A equals A. There we go, equation 1. And then resolve downwards for the 3 kilogram one, also using F equals ma, and get 3G minus T equals 3A. Call that equation 2. 1 add 2, automatic. I'm not even reading the question. 3G minus 1G is 2G. A plus 3A is 4A. So A is 2G over 4, G over 2, which is 4.9 meters per second squared. Substitute that back into 1. So T minus G equals 4.9, so T is 9.8 plus 4.9, which is 14.7 newtons. There we go. And that's that. And the method is exactly the same as the question earlier on. There's a little bit of difference here because we've got a 2 stages of motion type question. The question will lead us down the path nicely though, because it wants B, says find the speed of the 1 kilogram particle when the 3 kilogram particle hits the ground. Well, at that instant, when it's fallen 0.4 meters and the other one's risen 0.4 meters, the two have got the same speed. Velocities are different because one's going up, one's going down. In terms of speeds, it's the same. So as before, I can do that. S is 0.4 meters, that's why we had to change the units. U is 0, V is what we're after, A was 4.9 G over 2, and T not interested in. So it's the one without T, V squared equals U squared plus 2AS. So V squared equals 0 plus 2 times 4.9, 9.8 times 0.4, and then V squared, oh dear, nearly made a slight mistake there, forget the squared, I've done before, so just under 4, so V is going to be just under 2, let's have a look then, so 9.8 times 0.4, 3.92, and root of my answer is 1.979. Have they asked for it? They have asked for it, so I need to round it off, so 1.98. I'm going to keep that previous answer in there. I might be using that in the V squared anyway, so I might keep that later on. Because part C says, after the 3 kilogram particle has hit the ground, the 1 kilogram one continues to move. So what's happened is, it's gone from where it was up to here, which is my 40 centimeters, and then, as it were, I'll exaggerate it slightly, it then begins to act like a projectile. And what we're interested in is the maximum height. We want how far it then travels with this initial speed of root 3.92, just under 2 meters per second, but then its new acceleration. And the questions aren't as simple as this normally. You would have to, if it's going up a plane, for example, along the table, you would have to resolve again to find the new acceleration, the new deceleration, more often than not. In this case, the new deceleration is just g. So when I do suvat for this part here, that's what we're after. Let's call it h for height. U is 1.979 because it reminds me to use the answer. V is 0 because it wants it at the top where it's got maximum height, so it comes to rest. A is minus g because my acceleration now for this stage of the motion is g downwards, acceleration due to gravity, and t yet again not interested in. So I'm using v squared equals u squared plus 2as, and so v squared nothing, u squared, you know what, 3.92, let's be as accurate as we can, and then minus 2gh. So h is whatever 3.92 over 2g is, so let's square it, 3.92 divided by bracket 2 times 9.8 equals, still cancel out, equals fifth. 1.2 meters. Don't forget though, the question wants the total height. Let's have a check. Maximum height above ground level, so it travelled 0.4 centimeters. It then travels under gravity 0.4 meters under gravity, 0.2 meters. So total height is 0.4 plus 0.2, 0.6 meters. Okay. Notice though the start is exactly the same. The part A is exactly the same. Once we've got constant acceleration, once there's times involved, speeds involved, distances involved, we're looking at suvats. If necessary, in G we needed to use a different acceleration. And remember what's happened here is at the join, at this point here, what was V for that stage becomes U for the second stage of motion. You could, in theory, have done a speed time. I know how much you love speed time graphs because it wants a total height. So you could think about one acceleration, g over 2, a deceleration of minus g, and find the total area underneath. It's whatever suits you. There's nothing wrong with doing it in 2 stages like this, but you would have to potentially work out a new acceleration, a deceleration. In this case, because it's under gravity, nice and straightforward. And that gives you a feel for the other questions to have a go at now.